what can it do now is very different from what can happen in the future as well, right? Maybe 10, 20, 30 years down the road, these things are going to be exponentially much better than they are right now. So, just having a little peek into the real future. I mean, what is it that can really solve that we think right now that probably can't do?
Yeah. So, just to be fair, right? Currently, most of the work happening on quantum computers, actual hardware, is very small scale. There is no computer which can really solve a massive real life problem on a quantum computer today. Just to be fair, right? And I do see a path to that happen at least at the intermediate scale in say next 7 or 8 years. So you will have to start a bit early and you will have to create something called as simulators, which almost every quantum hardware vendor who is trying to build a quantum hardware has created, right? So everybody has come up with a quantum simulator. And our best path of solving software problems is really start doing softwares and start running them on a simulator. Right? So if you are really running something directly on a 70 qubit quantum machine at a large scale, there is really no way for you to test it back on a classical computer. Those problems are not solved here, right? So it is always better to start your algorithmic development at a smaller stage and test it against the classical logics that we have developed so far. Now, in Microsoft, I realized that there is also another approach to it, right? While, for example, we will all be focused on our holy grail of universal gate-based quantum computers, there is a lot that you can do in the optimization space by something called as annealing, right? And D-Wave really mastered the game of creating quantum annealers. But you can actually do a lot of annealing on classical simulators again, right? And this is in Microsoft terminology, this is called as quantum inspired optimizer or QIO. And that you can actually do at a large scale with the current compute power available on classical simulators. And it will still give you good enough results for optimization problems, especially yes no kind of optimization problems, right? And if you really look at your AI use cases, these problems really cut across about 70% of your use cases. So there is a huge potential to do this today while we still start experimenting on the software algorithms that will run on real large scale quantum hardware.